Thank you for joining me. Today we're going to move on. Instead of just talking about how to simplify radicals, we're now going to learn how to multiply and divide radicals. Today's focus is just the multiplying piece. We're going to take a day just to get really good at that before moving into the division. Now, a couple things to note about multiplying. First of all, the indexes must be the same. So here, I can't combine these two things because this one is a square root, that one is a cubed root. So the indices have to be the same. If they're not, then you can't multiply them together in this section. The other thing to note, is in order to combine them, both radicals must be real numbers. So if you're dealing with like a square root, you can't have two negative pieces to become positive. It doesn't work that way. Each individual piece must be real for them to multiply together, okay? Now that really won't be an issue in this class, but just a note, so come a college course or college algebra pre-calc next year, well, there it may become an issue. So what do we do? So first of all, you want to simplify, okay? You need to combine the expressions. So what I say is multiply the outsides and then multiply the insides. That's kind of my general rule, okay? And when I say multiply, what I mean is the numbers have to multiply together, okay? And then for any variables, remember you add exponents. So another piece of good news is from this section onward, we get to assume that all variables are positive. So starting in this section, the prompts are always going to say, assume all variables to be positive. And the cool thing is that means no more absolute value, okay? Because that would just get really complicated, just another step on top of everything else I'm asking you to do. So the previous ones, that's where I'm assessing your ability with absolute value. From this point on, we're not going to be concerned with it anymore. So let's take a look at this first example. So again, I need to multiply the numbers together. So here, 72 times 10 is 720. X cubed times x to the first, again, add exponents. So that gives me an x to the 4. X squared times x cubed, add exponents, 2 plus 3 gives me a 5. All right, so now that we have that, now let's start actually working to solve this and simplify it. Again, we don't have to worry about absolute value, which is really, really nice. But I'm going to go to my powers chart because 720 is a big, big number. Okay, so let's see what can divide 720. Now, here, the tricky thing about 720 is there's multiple numbers that look really good. So here, 720 is divisible by 4. But when you take 720, you divide it by 4, you have 180 left. Okay? Now what that tells me is there's probably a bigger number that could work. So here you have to be careful. You want to make sure you're getting the largest number. I try 9. 9 actually also works, and it leaves me with 80. However, 80 has another perfect square that could pull out, so that means I'm actually looking for something bigger. 16 actually works, but again, something bigger actually works better. So here the goal is finding the biggest number that works, and in this case, the biggest number that ends up working is actually 144. Okay, you can go all the way up to 144. 720 divided by 144 leaves you with 5. So I'm going to break this down. This is 144 and 5. Okay, so just one thing to be cautious about. Make sure you're pulling out the biggest number. So square root of 144 is 12. And then 5 gets left inside the square root. Now let's see about everything else. So here this is a square root, so 2 goes into 4 2 times, so x squared pulls out. 2 goes into 5 2 times, but that only gets me up to 4, which means I have one other y stuck inside, which would get me up to the 5. And then that's going to be the end of simplifying that one, because again, no longer do we have to worry about absolute values. So that is legitimately just the end. All right, let's look at our next one. So again, multiplying the numbers, 5 times 35 is 175. X to the 5 and x to the 1, again, you add exponents. That gets me up to x to the 6. For the y's, 3 plus 4 gives me 7. So the first step is you always want to combine the two radicals together. And now let's start simplifying. I go to my chart. I'm dealing with square root again. You try 4 and it doesn't work. 9 doesn't work. 16 doesn't work. 25, that's where it works. 175 divided by 25 leaves you with the whole number 7. So here this breaks down into 25 and 7. You know what the square root of 25 is. You know the square root of 25 is just 5. Leave some space, and now I put my 7 there. This is the square root. So how many times does 2 go into 6? Well, 2 goes into 6 3 times evenly. So I can pull out an x cubed. How many times can 3 go into 7? Well, that's also 3 times, but not evenly. 2 goes into 7 3 times, which gets me up to 6, but that's a 7. So there's one y left over. Okay, that last power of y is left over and stays stuck inside my square root. Obviously, again, I don't have to worry about absolute values, so this is going to be the end of my problem. All right, so here, if the numbers are outside the radical, multiply them separately and keep them out. So this is, I actually already kind of mentioned this. This is my general rule of thumb. To multiply outside, then insides, then simplify. Okay? That's kind of the general process I'm going to want you going through when you're solving these problems. So multiply outsides, 5 times 4 gives me 20. Now let's focus on the insides. 2 times 32 leaves me with 64. X squared, x to the first, 2 plus 1 leaves me 3. Y to the first and y to the fourth, 1 plus 4 leaves me with 5. So first I combine my radicals together. Now my focus becomes simplifying that radical. So I'm looking at the cube root, so that is a third power. And nice enough, 64 is actually on the list. The cube root of 64 is legitimately just the number 4. So this actually starts breaking down very nicely right away. The cube root of 64 is just 4. 3 goes into 3 once, so it just pulls that as an x. Now 3 goes into 5. Well, I'm sorry. 3 goes into 5 once also, but that only gets me up to 3. So that means I have 2 exponents left that have to stay inside the radical. Okay? Now this one actually just have one extra step to simplify it. 20 times 4. I'm going to combine that to 80. And that is going to be my final answer. All right, let's look at this one. Multiply the outsides. Negative 2 times 3 is a negative 6. Oh. Now let's start multiplying the insides. 9 times 18 leaves me 162. X squared times x to the third, 2 plus 3 is 5. Y to the third times y to the fifth, 3 plus 5 leaves me 8. So first I combine the two radicals. Now I'm going to simplify from there. So I looked at my powers chart. This time I'm dealing with a fourth root. So I'm looking at this column. And I have 162. Well, 162 divided by 16, not a whole number. 162 divided by 81, there it is. That's what I want. Okay? So it splits up into 81 and 2. All right, so what is the fourth root of 81? Well, look at your chart. The fourth root of 81 is the number 3. So that pulls out as the 3. And then the 2 is still inside. And of course, I'm going to leave myself some space for as I'm pulling out other things. 4 goes into 5 one time, so I can pull out an x to the first. However, that doesn't go in evenly. I still need one more exponent of x to get me up to 5, and that extra one has to stay inside the radical. 4 goes into 8 nicely twice. So that one doesn't have anything left over that needs to stay inside the radical. That one comes out completely. Then the last step is I can multiply these numbers on the outside. Negative 6 times 3 is negative 18. So I can write it like that. And that is my final answer. And then, of course, just to spice it up, make it a little bit more interesting, let's take a look at a geometry context. All right, so find the area of the rectangle in simplified form. Well, this requires you to remember how to find area. Now, I'm hoping that all of you remember area of a rectangle, okay? Length times width. So basically, all it's asking me to do is multiply these two things together. All right, so multiply the outsides. Well, there's only one thing on the outside, so that's pretty simple. And now the insides. 5 times 5 is 25. X to the first times x squared. 1 plus 2 gives me 3. Y squared times y squared. 2 plus 2 gives me 4. All right, so powers chart time. We're dealing with a cubed root. Now what you'll notice is actually nothing on that list divides 25. So because nothing on that list divides 25, there's actually nothing I can do with it. The 25 is just actually going to have to stay put. Okay, so occasionally that can happen, not often, because obviously the goal is I want you practicing your simplifying skills, but I do want to make you aware of the fact that sometimes it just won't. Sometimes it doesn't allow you to simplify. So that 25 remains completely inside the radical. How many times does 3 go into 3? Well, once. How about how many times does 3 go into 4? Well, once. But there's one left over still. I need one more exponent of y, and that one stays stuck inside the radical. And so that is going to be the final answer for this one. All right, so once again, a lot of good stuff here. Now, what I want you to do is now write me that summary. Take a moment after you're done with the video, summarize what you learned, a technique you're going to use to remember what to do or reiterate the steps. Do something to reflect on what you saw in this video. Have that ready for me tomorrow for when I check your notes, and come back ready to do your practice work in class.